you guys nag me. And then I want to use, what color am I feeling today? Today is Friday. I am so ready for weekend. So let's go with green. Tak ada kaitan pun. But that's life. Okay, so let's do a recap. Chapter 18, right? So what have we learned so far about chapter 18? We talked about semiconductors, we talked about conductors, we talked about insulators, and in general, we know that conductors have high conductivity. Conductors have, it's kind of hard to write. Okay, conductors have high conductivity and low resistance. What does resistance mean? It means that it impedes the flow of charges, or it impedes the rate of flow of charges. So low resistance. Okay, and then we talked about insulators have, the opposite to a conductor is an insulator. Use red now. So insulator, I'm recording, right? Right, okay. So have high resistance and low conductivity. So resistance, the symbol, ya Allah, the symbol is R, whereas resistivity is rho. Okay, so it's different. And then we have conductivity as this guy, that symbol. I forgot to look it up what that is. Have high resistance and then low conductivity. Okay, and then we also know that R is equal to rho length over A. Resistance is proportional to length, meaning to say when you have a longer length, lagi lama lah dia kena lalu obstacles tu. So it increases the resistance, whereas when you have a larger hole or a larger cross-section, okay, so this is your super long pipe, so banyaklah obstacle kat sini, lagi lambat your charges can reach the other end. And when you have a bigger cross-section, your charges can flow more easily compared to when the cross-section is smaller. And what cross-section should we use? Just imagine when you have something long, you will always want to cut it. So that is your cross-section. Okay, jangan cross-section menyengit, cross-section menegak. Okay, so that's the best I can do. That is your menegak. So cross-section potong, and then that is, the area for your cross-section is you cut it, that is your cross-section. So kalau circle, it's an area of a circle. If it's a square, it's an area of a square. A rectangle, okay, depends on the shape. Okay, so that is length, so it is in meters. Your area is in meters squared. This resistivity is in ohms meter. I hope I'm right. Because this guy is in ohms. Okay, resistance is in ohms. So this guy cancels out. This guy, we bring the meter to the other side. So we are left with ohm meter. Okay, RA is ohm meter, rho is ohm meter as well. Okay, so that is your conductor and insulator briefly. What else have we learned? We talked about resistors in series and talked about resistors in parallel. Okay, so resistors, the way that you add it, let me write, kenapa saya punya ni? Jangan buat hal. Okay, let's use purple. I rarely use purple. Okay, so R equals to rho L over A, right? Okay, so now let's talk about resistors in parallel in the circuit, right? So resistors in parallel, sorry, that's a capacitor. So resistors in parallel, okay, which means that the I flowing through them is the same, V1, V2. So this is in series. Your resistors have the same I. Okay, yang ni dah ulang berapa kali dah. Different voltages. And then the way you add it together is R equivalent equals to R1 plus R2. Okay, Haikal? Okay, and then we have resistors in parallel. R1, R2. Okay, so if I start my circuit like this, I have a battery over here. Doesn't really matter actually. So my I is flowing through here. My I needs to diverge because it's a water, it's like water, and then when it sees a junction, it has to split lah. Okay, so this is becomes I1, this becomes I2. So for a parallel, your I is not the same. However, your V is the same. V is same for parallel branches or parallel lines. Then your R equivalent is same. R equivalent is 1 over R1 plus 1 over R2. Okay, let's talk about the problem that we did yesterday. Am I missing anything that is very important here? Oh, ada lagi satu equation, forgot. It's this equation related to this dude over here. No. Okay, so we talked about resistivity. And I talked about resistors, but we have not talked about the delta R over R naught equals to alpha delta T. And then delta rho over rho naught equals to alpha delta T. Your alpha is your temperature coefficient. Temperature coefficient. This is your T final minus T initial or T naught, or T current minus T naught. Okay, so this is change in temperature. So always start with current minus initial or final minus initial. Always, delta will not change. So this guy is R. The question that they will ask you is R current, but we know R current is basically R final, okay? And then R naught is just your initial resistance. Okay, so alpha depends on the type of material. They will usually give you the constant, the temperature coefficient punya value, unless they want you to calculate for it. Okay, so this is a constant. And the same case for rho, delta rho over rho naught, alpha delta T. And then another form of this equation, I think you know this already, is R naught 1 plus alpha delta T. Okay, sama juga for the rho naught 1 plus alpha delta T. Sorry, tak kemas sangat. Okay, so now I want to go to the question that we did yesterday. Okay. What was the question? Okay, so remember that we calculated the R equivalent for 5 ohms and 20 ohms, which was 25 ohms. Okay, so that was our equivalent for this line or this branch. I'm going to use line or branch. Line tu maksudnya this whole, saya baik tak mencarut, this whole thing. Okay, so 5, 10, 10. So 10, this 10 ohm is not in parallel with this 10 ohm because there's a battery over there. So dia kacau kita lah. But the 10 ohm, 5 ohm and 25 is in parallel. So I know something in parallel will always have the same voltage, right? So when I combine these three lines into one, R equivalent, the voltage is the same. The voltage is still the same, even when I expand it to become 10, 5, 25, or when I compress it to become a single line to become RB. You don't remember what RB is. I think it's 2.93. Okay, so it has the same voltage. Okay, this is very important. It has the same voltage. So if I calculated the voltage from A to B is 5, contoh, 5 volt. Okay, so the 10 ohm has 5 volt, the 5 ohm has 5 volt, the 25 ohm has 5 volt. When I combine these three parallel circuits together to become 1 over 10 plus 1 over 5 plus 1 over 20, 1 over that whole thing, and I get the R equivalent, which is RB, the voltage across RB is still 5 volts. It does not change because it is still in between A and B. Asalkan this between A and B, which is what I calculated before, the voltage between A and B is 5. As long as they are still in the range, as long as they are still in AB, they will have 5 volts. Doesn't change. Okay. Okay, with that said, we yesterday, okay, benda ni bukan 5 volt. we found out that the V over here is 5.68. How did we calculate for that? We made it into RB. Okay, let's see what was RB. I forgot actually. RB is 2.94. Oh, I'm right. Oh, I said 2.93, I think. Okay, so 2.94 ohms, right? Okay, so this is, let me padam ni. Alamak, kalau saya padam, saya tak ada copy ni. Tak apalah. We are all smart, we can do it again. Okay, so my battery was 25 volt. And I know that my total resistance, okay, R equivalent for the whole circuit is 10 plus RB, which is 10 plus 2.94, which is 12.94. Okay, so now when I want to calculate the current for the whole circuit, I need to have the resistor for the whole circuit. And I need the voltage for the whole circuit. Okay, I'm going to repeat myself. If I want to find the current for the whole circuit, I need to know the resistance of the whole circuit. And I need to use a voltage that is supplying voltage to the whole circuit. So kalau kita nak cari benda yang, how do I say this? If I want to find something for the in the form of a total, macam mana cakap ni? I want to find the I total. That is what I want to find. So if I want to find I total, I need to find R total, and I need to use voltage total. In this case, our R total is 12.94. Okay, and our V that supplies the whole voltage for the circuit, the voltage for the whole circuit is 25. And our I is what we are trying to find. So this is the I that flows through the whole circuit. It is the I total. Okay, so this is the condition here. So V equals to IR. You can only use this when you have the R total and the V total. And then only you can find the I total. So here, 25. I is, we don't know, R is 12.94. So we found out that I is 1.93, okay? So this is when we want to find the total, which is kind of easy, right? Because you just have to find the total for everything and then easily use V equals to IR. However, the question says, what about the current flowing through 20 ohm, right? What about the current flowing through 20 ohm? Now, what is in series with 20 ohm? It is the 5 ohms. It is the 5 ohms. Remember, if I want to find an I for something, contohnya I want to find the I for this line. Okay, for this line, what do I call this line? Let me call this line, I don't know. Okay, the line between, no, I cannot say that. Okay, let's just say it's a line. Okay, so I want to find the I for the whole line over here. Okay ke, Aisha? Fatima? Oh, Aisha is here today. Are you okay? Okay, so no response. Okay, so I want to find the I for the whole line down here. Okay, let me use, okay, I'm muted. All right. So instead of just using R here, okay. Instead of using the R over here, right? The question is, kenapa tak pakai R that is 20 ohm? Kenapa kena pakai 25? The reason is because I am trying to find the I that is flowing through both of these resistors. So in order for me to do that, I need to add the two together. If I just use 20 ohms, then I'm actually not finding the I for this whole line. Why is it important to find the I for the whole line? Because they have the same I. And they will only have the same I if they are in series. Okay? I hope that makes sense. Okay, so again, why did I not use 20 ohms? Why did I use 25? Because I am finding the I for this whole line because they have the same I. For me to find that I, that particular I need to use 25 ohms. Okay, and then what is the voltage that I need to use? Okay, I'm going to ask you, what is the voltage that I need to use? Can I use 25 to find V equals to IR over here? Anyone? So everyone's like snoozing already. Baru recap.
No,
Afika, try.
no, we cannot use the 25 volt
Okay,
because the 25 volt is the total volt for is the 10 ohm yang atas tu.
okay, so 35 volt is the total volt that supplies the voltage for the entire circuit, right? So dia akan divide to all the resistors. So Afika, thank you Afika. But I want someone else to help Afika. What is the voltage that I need to use over here? What is the voltage that I need to use? Okay, I want to find the I for this entire branch. So I need to use the resistance for the entire branch. What is the voltage that I need to use?
5.68 volt.
Okay, 5.68. But why? What does 5.68 mean in this case? What does it represent?
It represents the circuit. It represents for
Apa dia?
eh, hello doctor.
Tak apa. What's your guess?
It's the voltage for the series circuit.
The voltage is for the series circuit.
For the,
Is that what you're saying?
it's for the circuit where the 20 ohm and the 5 ohm.
When the you're not clear sebenarnya, saya tak dengar. When the apa?
If the
Okay. Okay, dah takut ke nak cakap tu. Are you okay?
hello doctor.
Be scared. Okay, tak apa. Thank you, Nat Mango. So so I told you we want to find the I for the entire branch, right? So the resistance should be the total resistance for the entire branch, which is 25, which means that the voltage that I need to use is also the voltage for the entire branch. In this case, it is VAB, which is 5.68. Okay, so you need to use the voltage yang bersesuaian lah. If you, tadi kita cakap pasal I total. We want to find the I total. So we needed to use 25. And we needed to use 12.94, right? Because we are finding the I that flows through the whole circuit. However, when I want to find out what is the I that is flowing through this guy only, okay, dia bukan total, dia pecahan of the total. So this is, let's say I1. I1 is a fraction of I total. So in order for me to find out what is I1, I need to use the R for this branch only, which is 5 plus 20, and the voltage for this branch only. And what is this branch punya voltage? We found out from here, which is 5.68. Okay. If I wanted to find out what is the I flowing through here, okay, that's another good question. If I wanted to find the I flowing through the 5 ohms, how should I do it? I2, let's say. Okay, let me ask Virus. So if I want to find I2, is Virus there?
Yes, doctor.
Virus ada tak?
Ada.
Virus ada? Where's Virus? Ada tak
Hello,
Virus?
ada.
Senyap je.
Hello.
Okay, ada.
Doktor
Dia
dengar
dah
tak?
unmute tapi dia tak cakap apa-apa. Virus, can you say something?
Hello.
We can hear Virus,
Dengar.
Doctor.
Kenapa awak unmute tapi tak dengar?
Doctor,
Okay,
we
so
can
my
hear
question
Virus,
to
Doctor.
Virus is,
Doctor?
what is the voltage that I should use to find
Doctor?
I2? And what is the resistance that I should use to find I2? So what is the V? What is the R? Virus is not there. Okay, let me find another person. Is Danish there? Semalam saya panggil Danish, rasanya Danish
Doktor?
tak respond. Is Danish there? Or am I
Doktor?
muting
Yes, doctor.
everybody? Tak juga. Danish ada?
Yes, doctor.
Kenapa saya tak dengar korang ah? Ya. Oh, ada chat. Okay, let me see the chat.
Doktor.
No, I did not mute. Tadi saya dengar nut mango. Okay, cuba try again. Saya dah.
Doktor?
Doktor, kami dengar semua. Okay.
Doktor?
Kami dengar mereka.
Doktor.
Oh. Maksudnya
Doktor,
betul.
doktor, 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 doktor,
Memang.
doktor.
Oh, I take
Doktor?
my speaker.
I see.
Sekejap, eh. My speaker is not working. Okay. Ada saja masalah. Yang saya tuduh korang tak bercakap. Let me try now. Okay, can you guys say anything? Hello?
Hello?
Okay, dengar dah. Alright. Okay, dengar.
Virus
Okay.
nak jawab doktor.
Okay, Fairuz, let's go. Fairuz nak jawab apa tadi? What is the V and what is the R?
Doktor dah balik boleh tak doktor?
Apa?
Soalan doktor tadi.
Okay, soalan saya. I want to find I2. Okay, I2 is flowing through 5 ohm eh. Okay, let me zoom in now. Okay, let me kemaskan kejap. So I want to find I2. I2 flows through 5 ohm and kita dah tahu from we have our 25 battery and the voltage flowing through, the voltage through A and B is 5.68 volts. I want to find I2. I2 is the current flowing through 5 ohm. Okay. What is my V and what is the R that I need to use to find I2? Boleh guess? It's okay if you get it wrong.
Sekejap Buat dia 5.968 tu punya ada
Idea? Oh, Faris tengah cari. What's the R? Ke saya punya speaker rosak balik. I mean my earphone.
saya tak tahu doktor.
Tak tahu. Teka? 15 ke, 10 ke, 5 ke?
5.
5. Okay, betul. Okay, so Fairuz teka 5.68 equals to I2 times 5. Okay, jawapannya betul. It is correct. Why? Because we want to find the I flowing through this whole line. Okay, so this whole line only has a single resistor, right? It has only a single resistor, which is 5. And the voltage is the same voltage between A and B because it's parallel to A and B. So the voltage is 5.68. So betul. Okay, good job. Okay, next one. I'm going to ask, what is the current flowing, what is the voltage at 10 ohm? What is the voltage at 10 ohm? Okay, let me try asking Aliana Umaira. Betul tak saya panggil nama awak tu? Is Aliana there? Ke Umaira nak panggil? Are you there?
I can. Yes.
Okay. Okay, semangat. Okay, so I want to know what is the voltage over here?
25 minus with 5.68.
Okay, betul. 25 minus 5.68 volt. Thank you. Good. So Alena got it. So here we know that the total V is 25 and RB, the point from A to B is 5.68. So I am left with 25 minus 5.68 for this guy. Okay, which is, it's going to use my psychic abilities, which is 19.32. Okay, that was psychic. So 90.32, I hope I'm right. Okay, let's use calculator to double check. So 5.68. Number 32, yay. So I do have psychic abilities. Okay, so 25 is the total. It gave out 5.68 to RB. So it has to give out 19.32 to the 10 ohm, right? So, oops, padam tapi tak berjaya. Okay, so 10 ohm. Okay, so if I don't want to use Aliana Umaira's approach, which is minus the 5.68, because I have not figured out what is the voltage here. I just know what is the I. I have this I and I have this 25. So if I wanted to find out what is the voltage over here, I can say V equals to I, the I flowing through the whole circuit, 1.93 times with the R that I am finding the I, right? I'm finding the I at 10 ohms, so it should be 10. This is 19.3, which is what we got from just Aliana Umaira's approach tadi. Okay, so there are several ways to do it. As long as you understand what you're doing, makes sense, then you're good to go. The most important thing to know is your understanding of parallel and your understanding of series, current flowing in series macam mana, voltage in series macam mana, voltage in parallel macam mana. Okay, so that is the basis to understanding your circuit. Okay, I hope that was helpful for everyone. Let's move on to our circuit analysis. Okay, so reduce into simpler circuits. Okay, so let's do this together. Saya akan panggil random people as usual. So we have 35. Saya rasa macam lama sangat tak panggil Amsha. Can I call Amsha today? Is Amsha there?
Yes.
Okay, so how would you tackle this A problem? What is your step? Let's do it together. Okay. So am I waiting for Amsha or is Amsha speaking and I'm not listening?
You're waiting for Amsha.
Amsha senang je ni resistors je. This is just resistors.
Kena buat apa ni doktor?
Kena tambah, kena cari R equivalent.
Oh, yang
R2 is it in parallel with R5 or is it in series?
parallel.
Huh? Amsha, R2 is in parallel with R5. Okay, what is the condition to determine if something is parallel or not? What was the trick that I told you? R2 and R5.
You meet at the same point.
They have the same dots at the sides connecting them together. Okay, so if I write dot A, if I write dot A over here and dot B over here, is R5 connected to the same dots as R2? Sama tak?
Yes.
Tak sama lah. Ni B. A ni dia sambung dengan R3. Mana sambung dengan R5? So tak parallel.
Okay.
Itu okay je, rotan sekarang. Okay, so please take note of what Amsha said. Dia cakap R2 is in parallel with R5. It's not the case. So again, use the trick that I mentioned to you. So A and B. B is connected to R5. Great. A is connected to R3, which means that R5 is not in parallel with R3. So R2 is in series with R5. Tu je. Okay, don't use the hard way. Dia dah bersambung kat sini. If I have I flowing, the same I will flow through R5. So we know it is in series. Okay, so R2 plus with R5. Excuse me. So you get R25. Okay, and then if I were to redraw this, okay, so this is R25. Is R25 in parallel with R3, Amsha?
Yes.
Yes, why? Why? Rasa macam cakap dengan dinding lah cakap dengan Amsha ni. Amsha, why? Dengan tak jawab ni.
Dia
Dia jawab yes, doktor.
Okay, yes. Tapi saya tanya kenapa.
sebab dia meet at the same point.
Okay, the same 2 points kena 2 points, bukan 1 point je. Dia bertemu at 2 point. Okay. Alright, thank you Amsha. So R3 is in parallel with R25. Saya tak marah Amsha tau, saya menasihati sahaja dengan penuh kasih sayang. So jangan merajuk. Okay, so so this is R235. Okay, so your R equivalent is 1 over R3 plus 1 over R25 equals to 1 over R equivalent. So R equivalent is whatever that is lah. Okay, R35 is your R equivalent. So now I am redrawing this to become this guy, R235. Silap. 235. Okay, so now I'm going to ask someone who is very lucky. Let me ask, siapa yang saya selalu tak panggil? Siapa yang tak pernah kena panggil lagi? Zahil, okay, Afrina. Afrina saya rasa saya jarang panggil. Afrina, are you there?
Yes, doktor.
Okay, so is R1 in parallel with R4?
No.
No. Okay, is R1 in series with R235?
No.
Apa? Don't know.
Tak, bukan.
Apa? Jawapannya
No.
Jawapannya no. R1 is not in series with R35, 235. Sebab apa yang dia bukan in series?
Sebab yang dia tak connect dekat dot yang sama.
Okay, yang tu parallel. So tapi sekarang ni saya tanya, is R1 in series with R235?
Di series.
Jawapannya ya. Okay. You mesti nervous ni. Okay, so if ada I flowing through R1, the same I will flow through R235. So R1 is in series with R235, which means that the I will also flow through R4, and R1 is in series with R235 is in series with R4. So the R equivalent for the whole circuit is R1 plus R235, which is how we got over it over here. Kena ikut equation ya. Plus R4. Okay, so this is your total R. And R235, you got it from here. Okay. So if okay, macam tu lah kot. So that is your first one. Okay, so the second one, let's ask Redo. Is Redo there?
Yes, doctor, yes.
Okay. So is 50 ohms in parallel with 20 ohms? This 50 and this 20. Are they in parallel?
No, doctor, no.
Because
Because they are series, doctor.
they are series. Okay, good. So if I have current, it will flow and it will 50 ohms will also meet the same I. So it is in series. And also another trick to knowing if it is in series or in parallel is you put two dots between the ohm. Let's say this is A, this is B. 20 ohm should have A and B as well connected if they are in parallel. But in this case, only B is connected to the 20 ohms, which means that they are not in parallel. Okay. Okay, so now 50 ohms is in parallel with 20 ohm. Let me redraw this. Okay, this is kind of hard. Okay, ni buang. So let me draw. That is like a scribble. Let's use green for redrawn resistors, okay? So 20 plus 50 is 70 ohms. They are in series, so tambah aja lah. So R equals to R equals to 50 plus 20, macam tu. So this is R1. Okay, so that is my R1. So 40 and 20 and 70 and 20. So I'm going to ask someone to simplify this whole thing. Okay, so I'm going to ask, what time is it? Okay, ada lagi 15 minit. Tak apa, hari ni kita bersukaria dengan sikit dulu. Okay, Hidayah. Hidayah macam jarang sangat panggil. Hidayah, are you there? Is Hidayah there? She's not. Hidayah. Oh, Hidayah is not there. Okay, Hidayah gimana ni? Hidayah tertidur ke? Hajar. Can I have Hajar? Is Hajar there?
Yes, saya.
Okay, Hajar. How do I simplify this? What would you do to make it into R equivalent for this whole thing from A to B? What will you do?
I add the value because they are parallel.
Siapa yang parallel?
Empat-empat.
Empat-empat is in parallel. Okay, so let's test what Hajar said. So if empat-empat is in parallel, they should have the same dots connected, right? So let's say this dot is called C. Is C connected to 20 ohms? Tak kan? So C is not connected to 20 ohms. Kalau dia connected, dia kena macam ni. Betul tak? Okay, so here we can say that it's not in parallel. Okay, Hajar, try again. So 40 dengan 20, are they in series or are they in parallel?
40 and 20 series.
Series, okay. What about 70 and 20?
They are in series.
Series, okay. What about 60 and 90? So this is 90 and then this is 60. 60 and 90, are they connected by the same dots on the side?
Yes.
Yes, okay. Tu baru parallel, okay. So thank you, Hajar. So now they are in parallel. So if I were to redraw this, it would look like this. Okay, so this is 60 and this is 90. So now the R equivalent for the top line and the R equivalent for the bottom line is in parallel with each other. So A and B both connects to the 60 and the 90. So now, tadi kita tambah 40 plus 20 and then 70 plus 20. Now to simplify this whole kotak, I need to add 1 over R equivalent equals to 1 over 60 plus 1 over 90. So that is my R equivalent. So 1 over 60 plus 1 over 90, 1 divided by answer gets me 36. So R equivalent is 36. Ni dapat 1 over 36. So the R equivalent for this whole branch is 36. Okay, so selalunya my students akan gelabah tengok benda macam ni. So dia akan gelabah macam okay semua parallel. Memang sebiji macam apa yang Hajar cakap. Remember, use the trick. Okay, so if I am connecting A and B over here, if I have two dots A and B over here, figure out if these two dots are connected to the whole circuit. So B is not connected to the 20 on the other side. Sorry, B is only connected to 20. A is only connected to 70. 20 tak connected to A and B at all. So they are not in parallel. But when I add these two together, these two resistors together, they are now connected on the same dot. I mean, they are connected by the same dots on each side. Okay, so jangan panik lah. Tengok tu, use the trick first. Okay, so that is B. Oh, sorry, tak siap lagi. So we found out that is 36, right? 36. And we found out that is 70. So this is 36 ohm. So if I were to redraw this, okay, excuse me, 50, 20, and 36. This is from point A to point B is 36 ohm. This is my R equivalent from point A to point B only. Then I have my battery. Okay, so this is 20 and this is 50. To find my total I, which is the I flowing through the whole circuit, I need to find the total R. Okay, so now I'm going to ask another person to help me to find the total R. This is the easiest question among them. Let's ask Najwa. Okay, Najwa, what is the R that I need to use to find the total I?
Since it is serious, so we just tambah je.
Tambah je. So R equivalent equals to
21 tambah
20.
21 tambah 50
Sorry,
20 oh sorry 20 plus 50 and 36. So
106 kan?
106 ohm.
Okay, so what is the V that I should use here to find the I? Najwa? Hilang.
Yes.
Okay. So what is the V that I should use to find the I total?
V equal to V1 plus V2. So the total is 120 V.
Okay, 120 V. So to find, how do I find the I? V equals to IR.
V equal to IR.
Okay, so V use 120 ke pakai V1?
Bukan 120 doktor.
Betul? Tak, saya tanya awak. Nak confirmkan je. Okay, betul lah Najwa. So 120 equals to I. R equivalent which is 106. Okay, kena confident sikit. Tanya sikit je takut. Okay, thank you Najwa. That was good. Okay, so I, when we want to find the I total, remember we need to use the V total, which is always your battery, and the R total. In this case, it's 106. Okay. Berapa minit lagi? Tinggal 6 minit. Okay, let me do this one laju-laju Ya je laju. Okay. Padam tak. Okay, so let's see. R4. Okay. So this is like a complicated circuit. I have to admit. Okay, so here let's see. Don't panic when you see a complicated circuit. Don't panic. Use the trick. What's the trick? The trick is if the I flowing through the circuit is the same, or use the dot method. Okay, the dot method ni I don't know if it's legit or not, but that is my method lah. I don't know if it's from a textbook or I really don't know if it's legit. So just use it, okay, to find out if it's parallel or not. Okay, so if R3, I want to know if R3 is then parallel with R1. So let's see. I put the dots here. I'm gonna call my dot star and moon. Okay, suka hati lah kan nak panggil apa. Lepas tu I want to say, okay, R1. Is R1 connected to the star and the moon? So this is moon tau, bukan C. So the moon travels, okay, so it is connected to the moon, but it is not connected to the star. So R1 is not in parallel with R3. Okay, so we solved that. R1 bukan parallel dengan R3. Okay, now let's find out if R4 is in parallel with R3. So R4, is it connected to the moon? Yes, it's connected to the moon. Is R4 connected to the star? Yes, it's connected to the star. So R3 and R4 is in parallel. So now I can add them together using the right equation. The right equation for that is R equivalent. Let's call it 1 over R34. 1 over R3 plus 1 over R4. Okay, so that is how I find out the R34 over here. So now I can redraw this to make my life easier. I don't know if it makes your life easier, but it does make my life easier. So from this point or this point to this point is your R34. Okay, so kita boleh abaikan yang ni dah. So now I'm left with this guy, R34, R1, R2. Okay, next. R1 is R1 connected to R2. Again, use the same method. Now I'm going to call it, what should I call it? Let's call it, panggil nama. Okay, let me call on Gelabah tu. Okay, let's call it, okay lah, saya rasa saya dah lama tak kacau Haziq. So I'm going to call it Haziq, this dot. Saya bukan nak suruh jawab, saya nak panggil dot ni Haziq. Seorang lagi nut mango. Ni mango tau, bukan saya. This is nut mango. Okay, so Haziq kat situ, sebelah kiri saya. Sebelah kiri resistor 1. Nut mango is on the right side. So is R2, kalau R2 jalan-jalan, adakah dia akan berjumpa dengan nut mango? Jawapannya ya. Bila R2 jalan-jalan sebelah sini, adakah dia akan berjumpa dengan Haziq? Ya, jawapannya ya. So R1 is in parallel with R2 because they meet the same people, right? Network diorang sama. Power lah. Wait, jangan pada itu. Okay. So R1 is in parallel with R2. So now I can make my life easier again. And say from this point to this point, the the R equivalent is R12. And R12 I need to find out using this equation. R1 plus 1 over R2. Okay, so now I'm left with battery R34, R12. Okay, final question. Is R12 in parallel with R34? Okay, tadi kat sini Haziq, kat sini Mango. Cik suka hati dipanggil Mango, Nut Mango. So Haziq and Mango kan. So R34 jumpa dengan Nut Mango, but R34 does not meet Haziq. Okay, so dia macam ada terputus connection kat situ. So R34 is not in parallel with R12, which means that they are in series. So if I flow an I, it will meet R12, it will also meet R34. So they are in series, so just tambah je. So R equivalent for the whole circuit is R12, R112 pula. R12 plus R34. That is your answer. That is how you simplify the circuit or you find the R equivalent. And that is it for today's class. Does anyone have any questions before we end? No questions? So everyone's going to be cemerlang in this topic. Was it okay? Was it hard to understand?
Okay.
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 Yeah, Doctor.
All right. So take care, everyone. I'll see you next week. Do not forget your virtual lab video. Sorry, video lab virtual. If you're still confused, you can ask me. Don't forget your web assignment. All right. So take care. Bye bye, everyone.
Thank you, Doctor.
Have a
Thank you,
good
Doctor.
day.
Thank you, Doctor. Thank you, Doctor.
Bye.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Thank you, Doctor.
Welcome. Bye bye.